Hello everyone, my name is Noemi. I'm very happy to be here sharing with you this very interesting topic, the software hexagonal architecture. And first, I want to share with you a little bit about me. I have 13 years working in tech industry. When I first started, I was more focused on the hardware part, and I started as a tester. Then, as years went by, I changed a little bit to software. And right now, I am a QA, but I'm also a software developer. So I have those two roles. Today, we are going to have this agenda. First, we're going to take a look at what is the hexagonal software architecture. Then, we're going to have a look at a case study. Then, we're going to have a code walkthrough. So we're going to check what can we do in our code. Then I'm going to show you new videos of a demo, and then we're going to have our conclusion. So what is the hexagonal architecture? In 2005, Alistair Cockburn proposes this new way of structuring and communicating the parts of a software project. Officially, he called it ports and adapters, but I think that hexagonal architecture it's a name that it's more visual, and if you're like me that learns in a more visual way, it helps you better to have the name in mind. So he noticed that separating the business logic from the other layers of a project as the presentation and the infrastructure layer would help us a lot and would improve a lot the project and the performance and the organization and everything. So this is why he proposes this. And well, it's thought to be applied to web applications. It can be ported to other type of applications, but I am focusing on web in this talk. So why he came up with the idea of separating this business logic from everything else? Well, in the old designs, we would take our business rules, so everything that existed in the real life of a business, and then translate that to abstract concepts, to tables and columns of a database. This made us having all the logic and all of our business rules into the database. So the whole design of the application revolved around the database. And having business rules on the infrastructure, it is very difficult to maintain and very difficult to debug. So you would end up with store procedures with thousands and thousands of lines. I'm not exaggerating, I've seen store procedures with 10,000 of lines. So you can imagine to actually debug that when something's failing, it's very difficult. But also, what if you have business rules in your graphic user interface? You would have to change your business logic or your core every time you add a new button, you add a new field, you add a new functionality that the user wants, because everything it's very interconnected, very coupled. And if you change something somewhere, it's going to affect everything else. So that was a very, very important problem to solve. Also, another disadvantage of the classical layer architecture, it was that it wasn't very testable. You couldn't test your core before your database was all set up and before you actually have a graphic user interface. So if you wanted to start testing some functionality, you wouldn't be able to do that because you were depending on everything else. And it made it very difficult to have automated tests because there was no easy way for someone that wasn't human to use your application. So that was problematic, and this is why the hexagonal architecture born. In hexagonal architecture, the number 6 is not important. This might sound crazy, but as I already told you, it is just to illustrate something. So the concept here is that we can have several ports, and to each port we can attach several adapters to. So that's why we have a polygon, we have this figure with several sides, but it's just because of that. It doesn't mean we need an hexagon to work with this architecture. Could have been another type of figure, but the important thing is that you can attach the number of ports and adapters you need. And normally, a port is a use case. So we follow this rule, then everything should be fine. You can imagine a port from the architecture as your USB port in the computer. So imagine too that you have several USB devices that you want to connect to your computer. Those devices have different functionalities, and the way you can communicate with the computer is by the USB port. So our computer, the only thing that it's going to understand is a very important concept here of the architecture. This is called a command. So between the port and the computer and the devices, the common communication is going to be a command. As long as all of the devices are complying the protocol, or in our case, in the architecture case, the command, you are going to be able to communicate to the core. So that's the very basic functionality of the architecture. We can easily separate the hexagon in two parts, which is the driving and the driven side. The driving side, you can see it as the side we're going to receive our inputs. And the driven side, you can see it as the part we're going to send the outputs into our database. Okay, so a very beautiful concept you can see here in this type of architecture. It is the dependency inversion from our solid principles of software. Why this happens? Because if you think about the control flow of an application in this architecture, it goes from the driving side to the driven side, and the dependency is going also to be from our core to those parts. But dependency inversion only happens in the driven side because the control flow goes on one side and the dependency goes to the other side. So our database is going to depend on what our application, our code, our business rules are defining, not the other way. So we, as the core, are not depending on the technology or on the details or specifics of the database. It's the other way. But the control flow goes to the other side. That's why it's happening just in the driven side, this dependency inversion. Okay, so this is what I was talking you about. So in the classical layer architecture, we have our application, and our application is depending on what the database has. But with the simple use of an interface, we can define our interface in the code. So with the simple use of an interface, we're going to be able to reverse that dependency. And the application is going to define its interface, and the database is going to comply that interface. That's the way we can create this inversion. Now, we're going to see a case study. I called it Bookworms, which is the name of a bookstore. Let's say 5 years ago, some friends started a bookstore and they wanted a simple website because it was a small business. They have a small amount of money. They wanted to invest on it. And they called us to create their website. So we were young and reckless. We designed a data model that we would store in the database, but then we leaked business logic into the database. And this was our first structure. So a few devices connecting to the website. This business was very small. An API HTTP gateway, our site, a Lambda function, and a PostgreSQL database, a normal relational database. So let's remember something. This Lambda function, it is what AWS defines as a serverless compute service that is going to run your code triggered by events. In this case, I used the AWS frameworks to make the example. That's why I'm mentioning the Lambda function. But you can use whatever technology you want with this architecture. But for the example, we have our Lambda function. So in essence, this was our first design, and this was our design with the business logic linked into the database. Then the bookstore started to grow. Everyone was talking about it. Everyone was accessing the website, and they were having more sales in the physical store. So they decided to grow everything. They decided to open more stores, and obviously the website was sometimes irresponsive because of the requests. So they call us again, and we need to propose a solution to that. So we have way more number of devices connecting to the website. We decided to create microservices, and also we decided to keep those API HTTP gateway points, but also we wanted to add a queue because in future we would implement the event driven design along with our basic architecture. So we wanted those two, the HTTP gateway and a queue. If we talk about the AWS specific technology for the queue, it is called an SQS queue. So here, we wanted to have an SQSQ and the gateway. Those two were going to be our inputs to our Lambda function, which is our code. And we would store the data in a new database. We chose MongoDB because it is very easy to scale that one, and the performance is higher than the one that we had with SQL. So we would change the database and we would add the queue. Let's take a look a little bit closer to what or how our Lambda function changed, how our core code changed. So we have two inputs. Per input, we have an adapter, but we only have one port, that is the order creation port. As I told you, normally each port is a use case. So the use case we made here, it's the basic one, which is the order creation. And as I told you also, the way we're going to communicate the adapters is the command. That's the only thing our application will understand, the command. So we have our SQS adapter and the API gateway adapter in the driving side, the inputs. Then we have our application and the core business logic, where we can add any business rule you can think about. Anything you want to do with the information you are receiving, you are gonna put it here in the core business logic in the red circle. For example, we receive an order from one of those stores, of the physical stores, and we would like to know where is that coming from geographically. We want to know where that order comes from in order to maybe classificate or maybe to apply discounts or things like that. We can add in the core business logic. Now, what are we going to do with that information? So we're going to send it to the output port, the storage port. That port, if you remember, we had the normal SQL database. So that was existent. But we wanted to change to MongoDB. So we had two adapters. The first one, the SQL adapter, and the second one, the new one, the MongoDB adapter. So I crossed the first database because we are going to disconnect that one and we're going to add the new one. And how? Well, it's just a matter of implementing a new adapter. It's not that hard. And let's remember that this part of the infrastructure, it's in the driven side. So remember this diagram, because having this in mind when you are creating the project, creating the code, is very helpful, because you will know this way where to put your folders and your ports, the code of your ports, the code of your adapters, the core of your business rules. So everything you see here can be ported to the actual structure of the project, as we are going to see next. It's time for the code walkthrough. So remember our first diagram. So I want to talk to you about also the other files you see here. For example, the local stack, the serverless, the node modules, everything belongs to the frameworks I use to create the example. So we are not going to focus on that. I want to focus on the actual parts of the architecture that you are going to see here in the folders. But if you install all of those technologies and frameworks, you will see those folders create automatically. I also have some other helpers, like for example the AWS deploy.sh, which is my script that it's going to deploy the code, or the YAML from the Docker Compose that it's helping me to configure Docker container to run everything, or the push order message.sh, which is a script that it's going to help me to send an event through the queue. So all those are kind of helpers and configuration files. I am not going to explain everything, or I'm not going to explain how to create the project from scratch. I'm just going to focus on the parts of the architecture. So in source folder lives everything that has to do with the hexagonal architecture. We have the application folder app, we have the infrastructure folder, and which is the driven side, and we have the UI folder, which is the driving side. Inside the UI, we could have a graphic user interface. In this case, I didn't do that because I wanted to focus on the other parts, on the actual part of the architecture that we saw in the diagram before. But we could have a graphic user interface. It's just that when you have big projects or complex projects, I wouldn't um, recommend to have everything from the graphic user interface inside this same folder or inside this same project, because the more complex is your system, the more rules you're gonna have, the more files, classes, everything, it's going to be bigger. So what I would recommend is to combine this architecture with other models, for example, with the onion architecture, where you are going to be able to add layers and to organize better your project. This is one of the other beauties of the hexagonal architecture, that you can combine it with other patterns. So going back to the graphic user interface, what I would recommend is to have a different repository with all the UI, and then communicate with the backend. But for this example, I don't have a graphic UI. I just have the adapters for the API gateway, HTTP gateway, and for the key. So it is very simple. It is a very simple structure, very simple project. That's why I can have it here, everything here. Okay, so let's go back and let's take a look inside our application, which it was the yellow square in the diagram. So inside that square, it's going to leave our command because it is part of the application layer. It is going to leave our entity. The entity is like the analog of the command, because the entity is what we are going to send to our database. It is what we are defining that our database is going to adapt to. We also have the port folder, which is the definition of our ports. And we have the service, where everything is going to converge. We also have the dependency container, which is a very common practice in software developing. And it's going to be useful when we want to inject dependencies to our code. Okay, so the first thing, let's take a look at the command and the entity folder, which is kind of like the language between the input port and the output port. For the input port, the command, we are defining an interface that is called create order command. We have an ID, a customer email, an amount, and a source. Why a source? It's just because I wanted to add this field in order for us to take a look where is the order is coming from, just to have it in mind, to have it visible. In the other side, we have a type, which is defining the entity, meaning the information we are going to store in the database once it's already processed by the core. So in the output, what we are going to deliver to the database is an ID. Also the ID, we're going to keep it. The email, we're going to keep it. The amount, we want to keep it. And I added also this field called comments because I wanted to reflect how the information was going through our code, how the information passed through the application layer, through our business logic, and then goes to the database. And the last one is also the source. So I wanted to keep where that order was coming from. What was the origin? The HTTP gateway or the queue? Now, let's take a look at the definition of the ports, which are also interfaces. For the input one, the input port is receiving a command, which we already saw we created. So it is receiving that information and then gonna be processed by the business logic. And in the case of the output port, it is another definition of an interface, which is going to receive our entity, the order, already processed. Now let's take a look at the adapters. Here in the adapters, we have the specifics of our technologies. First one is the Mongo adapter. So as you can see, we have a connection string to it. This is very specific to MongoDB. This is in the documentation. And we also have the population of the entity with the information that is coming from the core. So as you can see, we are using also something very specific to MongoDB, which is the insert one, where we are populating the ID, the user, total, the comments, and the source. In the other side, we have what's going to be the adapter that we are going to deprecate, the SQL adapter, the Postgres adapter. So for that one, we also have the specific connection string to the database, which is different from the one we use for MongoDB. And we have the very common, very known SQL query, which is an insert. And we are going to insert also here. We were inserting the information coming from the core, the one you saw, the ID, the email, the amount, the comments, and source. Same one, but in a different way because it is a different database. Okay, now the adapters from the side of the UI, from the input. We have here first the API order creation adapter. And what we are going to populate here, it is the information coming from the event. That's why we populate here by calling the fields from the create order event, and we are putting them into the command. And on the other side, we have the adapter, but for the queue. So in the queue, same from the event, we're gonna take the information, we're gonna populate the comment. Next, the file where everything is going to converge, where we are going to implement our input port, and we are going to inject the output port. So here is very visible how by just commenting a line of code, we're going to make the change of the database. We don't need to do anything else in order to change the database. That's the magic. Because here it is the core, it is our business logic, and we don't have to deal with connection strings, with inserting information to the database. We don't have to deal with anything else but with the things we want to do with the actual information and how we are going to deliver those to the database. That's it. And this is all thanks to the ports. Yeah, because how we implemented them. So here we have a very simple business logic just to illustrate the architecture. And it's going to be adding the comments field I mentioned to you at the beginning. The comment is application layer adding comment. It is very simplistic. It's all we're gonna do, but that's the way we're going to see that our information coming from both inputs is being processed here. It's going to the database we want. That's it. Next, we're gonna see a series of mini videos I made to see in action what I just showed you. So let's take a look at the first one. The first one is when we had the old design that it was coming from the HTTP to our old Postgres database. So here we are we deployed our code with the help of the script I mentioned. And every time we deploy, we're gonna have an URL. So we're gonna copy that URL and we are gonna use Postman to send an event, an HTTP request. Okay, so we copy the URL with a post in Postman. We send the first order, ID 1, with the email, an amount, and the source, which is HTTP. And now we can check the database. And our order is there, stored in our database, and you can see that the comments are there. Application layer adding a comment. So here we can see that we sent an HTTP request, the information was processed, and the comments field was added. Now we are going to see the other input to the same database, the old one. Okay, so for this one, we are gonna use the script that is going to send the event with the queue, in the queue. we changed the ID. It's going to be our second order. We have another customer, another amount, and the source now is the queue. So we are going to send it. We use this script. And now we're going to check again our database. So we select all the orders, and there you can see we have the second order we sent through the queue. We have the source there, and also the comments that the information was processed by the core. Next, now we have changed to the new database. We are going to comment the SQL1, and we are going to deploy again because we changed the code of the core. So we're gonna, here, you see that we are commenting the old one, and then we need to deploy again the code because of the change. We need to wait a little bit. This is fast because the project is really small. Of course, if you would want to keep both databases, you could, but here there is no use because our actual solution involved having a database that could scale easily, that could perform better. That's why we are changing of database. Okay, so now we copy again the URL because we redeployed. And from the HTTP gateway, we are going to send now to our MongoDB database, the new one. So we change the ID. It's gonna be our third order. Change the user, the customer, the amount, and the source is the same, HTTP. We send the request. And now we check our MongoDB database. Here we have the third one. The third order, we have our new customer, the new amount, but we also have the comments layer, the application layer adding the comments, and the source HTTP, as you saw. It was coming from Postgres. And the last one, the queue to MongoDB. So this is our second input, our fourth order, and it's going to our brand new DB. We use the same script, but now we are changing to the full folder, order customer, the amount, and of course we keep Q as the source. And now we are going to use our script. We are going to run it. I'm going to push the message into the queue, and we can check again our database. So in the database, we can see we have a fourth order that it's coming from the queue, and it has the new information we sent. So, as a conclusion, implementing the hexagonal architecture correctly requires experience. Yes, you would have to have some experience or some experimented person that's going to be guiding the process. Yes, but the time and the effort you're going to spend on that, it worth it because you're gonna have a project that could last very easily for decades like this because it is a very good way of organizing your structure. You're going to prevent that your business logic it's in the other layers, in the infrastructure or in the presentation layer. And you are going to have a system that is very easily tested. The advantages of having a system that you can easily test is that you are very well, it's going to be very easy to have the pyramid testing that we should have in projects, which is the more the majority number of unit tests at the bottom, then integration tests a little bit less. And then in the point of the pyramid, we will have our end-to-end tests. Those should be the less number of tests. So if you have this type of system, you will be able to comply to this model of testing, and it's going to be very easy to test your whole system at different stages. You wouldn't have to wait to have a graphic user interface. You wouldn't have to wait to have your databases already set up. You would just start to test whenever you think is needed. Finally, the system is going to become resilient because you can have fallback mechanisms, and this can be achieved just by implementing new adapters. It doesn't matter what type of mechanism you want or the technology of it. You can just implement new adapter to your port. That's it. It's going to be maintainable because of the separation of concerns. Because as you can see, it is very clear in the code to which part of the architecture it belongs. So let's say you have new members in your team and they take a look at your structure at your project. They are going to be, well, the code is very easily um, mappable to the architecture. It's readable and it's hence easy to maintain. Also, it's going to be extendable because you can add new technologies and you won't have to worry about the specifics, which is also making the system robust because you don't depend on anything that's happened outside your application. That's it. This is the bibliography I used. So the first one is the original documentation by the person who came up with this architecture, and the other ones are blogs that have very useful information. Thank you. This is a QR code in case you want to take a look at the code, you want to play with it, maybe you want to experiment with it or add your own code. You can clone it and just play with it. This is my contact info in case you have questions, in case you want to add me as a contact in LinkedIn. And that's it. Thank you for listening.